Hello. This is our first lesson for Math 150 College Algebra. This is actually a review. I find that students coming into the course don't know how to do certain operations, even though it is an expectation that you know this coming into the course. And these things for today's lesson will be operations with fractions, simplifying radicals, and distribution. So operations with fractions is going to be used a lot in this course, and when we see it, it will be done very quickly because it is expected that you know it. So in other words, when I am adding like terms, I am going to sometimes have fractions. I'm going to do it very quickly because you know how to add like terms and you know how to add fractions. So if you don't know this, you have to really go over this video multiple times until you feel like you know it. And then I would even go and make up some problems of your own and practice, and then do your MyLabs Plus. In addition to that, when we get to radical equations, we're not only going to be adding fractions, we're going to be dividing fractions on top of fractions and adding fractions on top of fractions. So it's going to get hairy if you don't know your basic operations of fractions. So it's important that you know this before you proceed with the course. Okay, so we're going to begin this lesson by adding fractions. 1/3 plus 4/5. The first thing we have to do is find a common denominator between the two. That means the denominators have to be the same. We are not changing what the fractions represent. In other words, how much, the quantity they represent. We're just making them look different, yet they represent the same number. So we should start with the largest denominator, which in this case is the 5. 3 does not go into 5. So then we take 5 and multiply it by 2. 10. 5 times 2 is 10. 3 does not go into 10. Then we take 5 and we multiply it by 3. 15. 3 does go into 15. So 15 is our common denominator. So we want both denominators to be 15 without changing the value of the fraction. As far as 15, 1/3, 5/15 is the same as 1/3. How did I come up with 5? Well, I look at the denominator and I see that 3 has to be multiplied by 5 to get 15. Let's go over to the next one. We have 5. How do I get from 5 to 15? Well, 5 has to be multiplied by 3 to get to 15. So I multiply the numerator by 5. And so I have to multiply the numerator 4 times 3. So I'm multiplying the numerator and the denominator by the same thing. Once I get a common denominator, I can add the tops and just bring the bottom along. So 5 plus 12 is 17, and the denominator stays 15. Now, we could say we're done there. This is a perfectly okay fraction. It is called an improper fraction, but there is nothing improper about writing it this way. However, sometimes we want to change it into a mixed number. When the numerator is larger than the denominator, we can change it into a mixed number. We do this by dividing 15 into 17. 15 goes into 17 one time. 1 times 15 is 15. Then we subtract to get 2. So we have a remainder of 2. And so our answer is 1 2/15. So we have changed it from an improper fraction to a mixed number. Now let's change it to a decimal. So recognize that 17/15 is the same as 1 2/15. Now we're going to see what that equals as a decimal. We start out the same way in that 15 goes into 17 one time. And then we do 1 times 15, which is 15, which gives us a remainder of 2 when we subtract them. But now we change the 17 to 17.0. Because we have a remainder, we're going to continue this on. And we bring that decimal point up here as well. So we bring the 0 down, and we have 20. So we say, how many times does 15 go into 20? And again, the answer is 1. This time, though, when we multiply 1 times 15 and we subtract, we have a remainder of 5. So we still have a remainder, so we change this. We put another 0 here because 17.00 is still 17. So we haven't changed this number at all. We carry down the 0 and we say, how many times does 15 go into 50? The answer is 3. 3 times 15 is 45. So we say 50 minus 45 gives us 5. Again, we have a remainder, so we have to continue the process. We add another 0, because again, it's not changing our number 17. We bring the 0 down and make it 50. We say 15 goes into 50 3 times. 3 times 15 is 45. And our remainder, once again, is 5. Now, notice this pattern. This is the same thing. We got 50 minus 45 and 50 minus 45. This means we are going to continue to get this repeating pattern. So, to signify that this 3 is going to continue to repeat, we put a line over it. And we don't actually need this second 3 now that we see it's repeating. So our answer is 1.13, and the 3 is repeating. And once again, 1.13 repeating is the same thing as 17 over 15, and also 1 2/15. All 3 of these representations represent the same. Now, for example 2, we're going to have 3 fractions added together. 1/4 plus 3/8 plus 1/2. So again, we have to find a common denominator. So we have a 4, an 8, and a 2. And again, we start with the largest denominator, and we say, does 4 go into 8 evenly? Yes, it does. Does 2 go into 8 evenly? Yes, it does. So 8 is our common denominator. Now, if they did not go in evenly, we would then multiply 8 times 2, 16, check them again, and so on and so forth. But they did, so 8 is the common denominator. Second fraction, The 3 over 8 already has 8, so I don't have to do anything to it. So I'm just going to put my 3 up there. The first fraction, I made the 4 and 8. I did that by multiplying by 2. So since I multiplied the denominator by 2, I have to multiply the numerator by 2, and 1 times 2 is 2. And we should look at this and automatically know that 2/8 is 1/4. So again, I'm not making it a different amount or quantity. It is still 1/4 is 2/8. It's the same amount. Now let's go over to the 1/2. The 2 becomes an 8, and to do that we multiplied it by 4. 2 times 4 is 8. So as you can see, you have to know your multiplication tables. Some of you don't. You absolutely should not be in a college level course if you don't know your multiplication tables. So you have to do a little extra work. You have to learn them. Go back to YouTube, type in multiplication tables, start listening to them. You should know at least 1 to 12 by heart, and all your perfect squares. Okay, so since I multiplied the denominator by 4, I'm going to multiply the numerator by 4. 1 times 4 is 4. Now I'm going to add up all of my numerators. 2 plus 3 plus 4 is 9. And then of course I have the denominator of 8. And so 1/8, 9/8 is 1 1/8. Or 1.125. Actually, let me go over that one with you, just because this is what we call a terminating decimal. The last example went on and on and on, so we had to put the line above the 3. This one does not. So 9/8 is 8 divided into 9. That goes one time. 1 times 8 is 8. So we subtract and get a remainder of 1. Since we are not changing it to a mixed number, we're changing it to a decimal. We put our decimal point here and add a 0. 9.0 is the same as 9. So we drop the 0 and we get 10 down here. 8 goes into 10 one time. Bring your decimal up here also. 1 times 8 is 8. And now we have a remainder of 2. So we have a different remainder here, so this is a different problem. It's not repeating itself. We drop the 0 and get 20. And then we know that 8 goes into 20 2 times. 8 times 2, or 2 times 8 is 16, which gives us a remainder of 4. Drop another 0 because we still have a remainder. 8 goes into 45 times. And 8 times 5 is 40. So now we have 0 as our remainder. So we can stop once we get 0 as our remainder. And this is our decimal equivalent. Okay, let's do another one. So again, we're adding fractions, so we need a common denominator. We start with the larger number, the larger denominator rather, which is 4, and 2 does go into 4, so 4 is our common denominator. first fraction, the denominator didn't change, so neither does the numerator. The second fraction, 2 was multiplied by 2 in order to get to 4. So we have to multiply the numerator times 2. 3 times 2 is 6. Then we add the top numbers, and the bottom number just comes along. So we have 11 over 4. We can change that to a mixed number. 4 goes into 11 2 times evenly, and it has a remainder of 3. And so that would be 2 3/4. Or 2.75. If I were to take 4 and divide it into 3 the way I did previously, I would get 0.75. So that can also be written 2.75. Now we have mixed numbers added. We can actually do this one of two ways. So I'm going to show you both ways. The first way would just be to put one on top of the other, line up the fractions and the numbers, and then we would add the numbers. So the whole numbers, add the whole numbers, which is 3, 2 plus 1 is 3. And then for the fractions, again, just as before, we have to have common denominators. So I'm going to change 3/4 so that the denominator is 20, because between 4 and 5, 20 is the common denominator. So that would be 15 over 20. You can stop the tape and do that yourself if you aren't sure how I got that. And then the bottom one, in order to make the bottom of 20, that becomes 4 over 20. And then 15 plus 4 is 19. And then we keep the 20, the denominator. So that's one way to do that. All right, the second way, I'm going to do it again. Same operation, only I'm going to do it changing them to improper fractions. We do that by multiplying the denominator times the whole number. 4 times 2 in this case. We're multiplying, timesing. And that would be 8. Then we're going to add the numerator to that. So we have 4 times 2, which is 8. 8 plus 3, which is 11. So that becomes 11 over 4. Next one, we have 5 times 1, which is 5, plus 1, which is 6. So we have 6 over 5. So we're kind of doing the opposite of what we do when we change improper fractions to mixed numbers. Now we have to have a common denominator again, so that's 20. So the top one becomes 55 over 20. You know, you can pause and try and do that on your own just to see how that works. And we've already done plenty of problems doing that, so I won't do it slowly. And the bottom one becomes 24 over 20. Again, you can pause it and do that on your own to see if you get the same answer. Okay, now we're going to add the numerators, so that makes 79 over 20. And we can change this back into a mixed number. So 20 goes into 79 3 times evenly, which gives us 60 and a remainder of 19. So we get the same answer no matter which way we do it. So that's it with addition. Let's go into subtraction. We've got 5/4 and 3/2. And when you're doing adding or subtracting, the first few steps are exactly the same. Find a common denominator. So in this case, the common denominator is 4. 5/4 minus 6/4. The denominator is going to be 4. Just like with addition, the denominator does not change. However, we got a problem here. We cannot take 6 away from 5. Well, we can, but our answer is not positive. See, think of this as I have $5, but I owe someone $6. That means I actually am $1 short. So that's -1. So that equals -1/4, and we bring the negative out in front of the fraction. Okay, again, with subtraction, just like addition, we can either change these into improper fractions, or we can just go ahead and borrow. Or in this case, we won't have to borrow. We can change it 2 3/4. I'm going to have a common denominator, so that's going to change to 2 15/20. And I'm going to stack them one on top of the other, and this bottom one becomes 1 4/20. So I found a common denominator for the fraction portion. I just left the whole number by itself. Now I'm going to subtract this time. I want to always, when I'm doing subtraction, even when it's with whole numbers or decimals, I want to start with the right side. 15 minus 4 is 11, so that becomes 11/20. And 2 minus 1 is 1, so it's 1 11/20. And I could have instead changed these. We've got 2 3/4, which becomes 11/4, minus 1 1/5, which becomes 6/5. Then you want to find a common denominator. So even when we are adding these numbers, same steps so far. We got 55/20 minus 24/20. And so we do 55 minus 24, which is 31. And the 20 stays 20. So the answer is 31/20. Now, just to compare that with the answer we got before, we should change that into a mixed number, just to see if they're the same. 20 goes into 31 one time evenly with a remainder of 11. So we have 1 11/20. And that's our final answer. And as you can see, they're the same thing. Now, sometimes when you're doing subtraction, you have to borrow. So we're going to do one where we have to borrow. Just like with whole numbers and decimal numbers, sometimes you have to borrow. So if you change these first into improper fractions, you don't have to borrow. So that is an advantage to always changing it first to improper fractions. But let's just look at it a different way. Let's do 5 1/5, but we're going to change 1/5 to 4/20, because once again, we're trying to find a common denominator. 3 1/4 becomes 3 15/20. Now, 15 cannot be taken from 4, so you may be tempted to think this is a negative number. But what you have to look at is the fact that as a whole, 5 is bigger than 3. 5 in some fraction is bigger than 3 in some fraction. So we have to borrow, because we are actually taking less from more, which gives us a positive answer. So we have to borrow. So we're going to make this 5 a 4. And we're going to add the 1 that we took from the 5 to the fraction. Only we don't want to think of it as 1, because that makes it harder to add. What we want to do is thinking of it as 20/20. Think of that. 20/20 is 1. But by making it 20/20, it allows us to add that because we have a common denominator. So that becomes 4 and 24 over 20. And the bottom one we're just going to leave alone for now. Just going to write it just as it is. 3 and 15 over 20. And now we're going to subtract them. So now we're going to start with the fractions as we did before. I'm going to do 24 minus 15, which is 9. And keep the 20. And then our whole number is 4 minus 3 is 1. Check to see if we can reduce 9 over 20, which we can't. So we're done. Okay, the next topic is multiplying fractions. Actually, multiplication is far easier than division. No common denominator is necessary. You simply multiply the numerators and then multiply the denominators. So this becomes 4 over 15. Look to see if you can simplify it, and you can't, so this is the answer. I want to show you a couple different ways to write multiplication. We very rarely, we'll pretty much never use this symbol times in algebra because it looks like an X, and we're going to start using the variable X to do things. So we're more likely to put parentheses around our numbers or a dot between our numbers. So, but again, same idea, you multiply the top numbers and then you multiply the bottom numbers, and so then you can keep it in this form since this is simplified, or you can change it into a mixed number or a decimal. But this would be, in this case, the decimal would, and that would be 1.875. Okay, another way, like I said, you could have the dot in between them, but that's the same number. It just wanted to show you that that still means to multiply, so that's 15 over 8. Another thing is that both fractions don't have to have the parentheses. For instance, up here, this could have just been the 5/4 with no parenthesis, or the other way around. Okay, last with fractions is that we divide them, and that again can be written in different ways. So I want to do a couple of them just to show you the different variations. This one right here is 1 divided by 1/4, and we're using a fraction bar. So that's 1 divided by 1/4. This is also very easy, super simple. The first fraction we keep the way it is, but I'm going to write it as a fraction. 1 can be written 1 over 1. We change it to multiplication, and we flip the second fraction so that 1/4 becomes 4 over 1. And then we're back to our multiplication rules, which is that we multiply the top, multiply the bottom. And 4 over 1 is the same as saying 4. So very simple. Here we have a double-decker fraction, 7 over 20 divided by 1 over 4, and so we're going to change it to multiplication. So it's 7 over 20 times 4 over 1. So we multiply the top and then multiply the bottom, and we have 28 over 20 which can be simplified. One way you can tell if something can be simplified is to think of its multiples. Like 28, let's see, that's 14 times 2. And then I can break the 14 into 7 times 2. So I'm just going to show you what my mind is doing when I try and figure out, can it be simplified. 28 can be broken down into 7 times 2 times 2. See how important it is to know your multiplication tables? And honestly, it just is threaded throughout this course in algebra. We build nearly everything we do builds on knowing your multiplication tables. So don't think that's a small feat. And then 20 broken down to primes is 5 times 2 times 2. Prime number, by the way, means that it cannot be divided by any number except for itself and 1. I mean evenly divided. So we see we have 2 over 2, which is the same as saying 1, right? 2 over 2 is 1. And this second 2 over 2 is also 1, so it cancels and we have 7/5 left. So that breaks down to 7/5. You know, the shortcut is to think, well, 4 goes into 28 and 4 goes into 20. So 28 divided by 4 is 7, 20 divided by 4 is 5. But if you struggle with figuring out what divides into both, break it down to its primes, which we're going to work more on breaking numbers down to its primes in a minute. All right, here's another way to write division. So that division sign becomes a multiplication sign. And then again, we flip the second fraction. So we change it to multiply, and then 2 over 3. Multiply straight across so that we have 10 over 12. The largest number that goes into 10 and 12 is 2, so that becomes 5 and 6. 5, 6. So both are divided by 2. There's another one. 1/2 divided by 3, which is the same as saying 3 over 1. So always change your whole numbers to fractions by putting them over 1. That's the same as saying 1/2 times 1/3. And that becomes 1/6. Because we multiply the top and the bottom, can't be simplified, we're done. So that concludes the fraction portion of this review. We still have more to review. Okay, now we're going to do the distributive property. We have what we call a monomial because it's a one-term expression here, 5, times what we call a binomial because it's 2 terms, 3x minus 6. So we are going to distribute because we want to simplify this. Right now we can't solve it because it's an expression, not an equation. It doesn't have an equal to sign. So we're not solving, but we want to simplify it. We cannot do what's in the parentheses first like our dear Aunt Sally tells us to do, because 3x and 6 are not like terms. You cannot add and subtract unlike terms. But you can multiply unlike terms. And this 5 is being multiplied to this entire thing. So we're going to take it in parts, or distribute the 5. We're going to multiply the 5 times 3x, and then we're going to multiply it by minus 6. So 5 times 3x is 15x. And then 5 times minus 6 is minus 30. And that's as far as we can go. All we did was distribute. Can't solve because there's no equal to sign. Next we're going to do a binomial times a binomial. A A binomial means it's two terms. So in the first parentheses we have two terms. In the second parentheses we have two terms. Now some people use what they call FOIL, but you can only use FOIL when multiplying a binomial times a binomial. So the F in FOIL is first, O is outer, so first terms, the 2x and the 3x, first in each parenthesis. Multiply them together. O, outside, 2x and 4, minus 4 on the outsides of the parentheses. Inside is your 5x and 3x, and last is the ones that are last in each parenthesis, which is 5 and negative 4. But I'm actually going to do it using the distributive property just to show you it's the same thing. This 2x has to be multiplied to each term in the next parenthesis, just like before. 2x times 3x is 6x squared. Don't forget, x times x is x squared. So that would have been the same as multiplying your first terms. Then we're going to multiply the 2x times the next term. 2x times minus 4 is minus 8x. That would have been the same as doing outside terms. Now we're going to take the plus 5 and multiply it times both terms. So again, it's just distributive property. So 5 times 3x is a positive 15x. So we're going to put plus 15x. And then the 5 times the minus 4 is minus 20. Notice that we end up with two terms that are like terms. So we can combine those two terms, negative or minus 8x plus 15x. So we have, I owe $8, but I have 15. It means after paying that bill, I'm left with 7. And it's a positive 7, I'm up 7. Nothing else is like, so we're going to just bring it down. And this is as far as we can go. No more like terms. It doesn't have an equal to sign, so I cannot solve it. I'm done. Now we have a binomial times a trinomial. So we're going to have to use the distributive property. There is no FOIL for this. 2x times 6x to the 4th, then 2x times minus 3x, and then 2x times positive 4. So we have 12x to the 5th. That's 2x times 6x to the 4th. And then we have minus 6x squared and then we have plus 8x, and we have multiplied the 2x times each and every term. So we're going to do the same with the minus 5. Remember, it's a minus 5. Minus 5 times 6x to the 4th, minus 5 times minus 3x, and then minus 5 times positive 4. So minus 5 times positive 6x to the 4th is a negative or minus 30x to the 4th. Then a minus 5 times a minus 3x, a minus times a minus is a positive, so be careful with that. That's one of the biggest mistakes people make with their signs. Minus and a minus is a positive. It's a positive 15x. And then a minus 5 times a positive 4 is a minus 20, or a negative 20. And now we're going to see if we have any terms we can combine, which the only terms that are like are our 8x and our 15x. So we can combine them. They're both positive, so that makes it easy. That's 23x. And we also want to put this in what's called descending order. So x to the 5th, that's your largest power. So we're going to put that term first. And then I like to cross it out, just so I know I did it. Next one will be x to the 4th, so we got minus 30x to the 4th. That sign has to go with it. So we got minus 30x to the 4th. And once again, I'm going to cross that out because I'm done with it. And then we've got a minus 6x squared. Take that sign with it. Don't leave that sign. Now I've got to combine my 8x and my 15x, which is 23x, and it's a positive. So it's plus 23x. And last but not least, minus 20. And even though that looks really long, that is simplified. Again, there is no equation, so there is no solving it down to a number. This is it. Okay, the last concept we're going to cover today is radicals. So that is square roots in this case. I mean, it can be more than a square root, but we're just going to do square root. So one thing to realize is an alternate way to write this is 25x cubed. And put parentheses around it all to the 1/2 power. So that idea of a square root is that to the 1/2 power. So we're going to actually simplify it, so I'm going to bring it back to where it was. Only I'm going to break it up and put the square root of 25 times the square root of x to the 3rd, but instead of doing x to the 3rd, I'm just going to do x times x times x. Okay, so 25, hopefully you know the square root of 25 is 5, because I'm just looking at a number that multiplied to itself would give me 25. But I'm going to break it down just to show it another way. Let's break 25 down into 5 times 5. This is breaking it down to its primes, like we said before when we're simplifying. So we have 2 5s, 2 of the exact same number. So the square root of 5 times 5, or the square root of 25, is just plain 5. Over on this side, we can cross out our 2 x's, just like over here we can cross out our 2 5s. And we bring 1 out of the square root to the outside of the square root. But we have this x still underneath the square root because there's not another one to cancel it with. So we have to keep it underneath the square root. And we multiply these together, we get 5x square root of x. And that is simplified. Okay, let's do another one. In this case, we got square root of 32x. So we're going to break it down to 2 different things. The square root of 32 times the square root of x. Square root of 32, this one's not a perfect square. So we have to break it to its primes. We start out with any combination that gives us 32, except for we never want to use 32 times 1. We never want to use the number times 1. So we could do 16 times 2, We could do 8 times 4. And so, again, knowing your multiplication tables really helped there. I'm going to do 16 times 2. 2 is a prime, so I'm going to circle it just to remind myself it's still there, but I don't have to break it down anymore. 16, I'll break down to 8 times 2. You could have done 4 times 4. 2 is a prime, so I'm going to circle it just to remind myself it's still there. 8. 4 times 2 is 8. Again, circle that 2. And then last but not least, we have 4 can be broken down into 2 times 2. Now they're not always the same exact number. I'll do another one in a minute just to show you that. But what this means is that 2 times 2 times 2 times 2 times 2 is equal to 32. All these 2's multiplied together gives me 32. Just as before, for every 2 that are the same, one comes out from underneath the radical sign. There's 2 more that are the same, so it comes out underneath the radical sign. And then there's 1 left, so it's got to stay under the radical sign. Okay, that's the square root of 32. Now the square root of x, can't simplify it because there is not 2 of them or more, so it's just the square root of x. Now we're going to multiply everything together. 2 times 2, these are our numbers outside of the radical. Multiply them together, we get 4. Multiply square root of 2 and square root of x, and we get square root of 2x. And that is the square root of 32x simplified. Okay, let's do one more. Let's do the square root of 40. Again, you can start with 2 times 20, 10 times 4. However you want to start, you can start. 10 times 4. 10 becomes 5 times 2, and they are both prime numbers. Prime number meaning nothing except for 1 and itself can be divided into it. So, in other words, 5 can only be 5 times 1. 2 can only be 2 times 1. There's no other combination. 4, it can only be 2 times 2. But it can also be 4 times 1, sorry. 4 can be 2 times 2 or 4 times 1. But 2 can only be 2 times 1. So it's prime. Now for every 2 I have that are alike, I'm going to cross them out. These 2 are 2's. Cross them out, bring 1 out. Nothing else has anything like it to cross out. So I'm going to put them back under. So that is 2 square roots of 10. Now if I had put that in my calculator, I would get a run-on decimal, a decimal that, well, it's called a irrational number. And that is, I would have to round an irrational number, which means it would not be an exact solution. So if you're asked for an exact solution, that would not be it. You would not be able to put, let's see what that is. What is the square root of 40 if I put it in my calculator? It's 6.3245553203 and a bunch of other numbers. So I would round it to 6.3, but the answer is not 6.3. The answer, that's not the exact answer, that's an estimate. But exactly the answer is 2 square roots of 10. So that's simplified. And the last thing I want to show you is factoring. We're going to look at factoring. So factoring is the opposite of the distributive property. So when we distributed, we were multiplying the outside number to the inside terms. We're going to do the opposite of that. Okay, so to do this, we look at each term to see what number they have in common that divides into each one. In other words, 6, 18, and 30. 2 goes into each of them. So it could be that we divide out a 2. But also 3 goes into each of them. And also 6 goes into each of them. So you have to make sure you get the greatest common factor. So 6 can divide into each of these numbers evenly. So the first thing we're going to do is take out a 6. Or factor out of 6 is the proper way to say it. And then I'm going to look at my variable terms, x to the 5th, x to the 7th, and x. My variables, they're in each term, and the greatest common factor is x. Okay, notice that even though it's called greatest common factor, the number is smaller than most of them. Now what's left? What I'm doing is I'm dividing each term by 6x. So 6x to the 5th divided by 6x, well, 6 divided by 6 is 1. X to the 5th divided by x is x to the 4th. I'll take a little sidebar over here and explain to you why that is. We've got x times x times x times x times x. That's x to the 5th because there's 5 of them. And on the bottom we have x. And the x over x cancels, or another way to say that is it's equal to 1. So what we have left is x times x times x times x times 1. The 1 isn't going to change anything, but we have 4 x's multiplied together, which is x to the 4th. The shortcut is to subtract your powers. If your bases are the same, they have to have the same base, you can subtract your powers when dividing. Alright, now let's move on. Next one we're dividing 6x out of. So 18 divided by 6 is 3. And then x to the 7th divided by x is x to the 6th. Last one, we're going to divide out 6x. 30 divided by 6 is 5. Don't forget this is a subtraction, so it's minus 5. X divided by x is 1, but we don't need to put times 1. And then end the parenthesis. These are equivalent. 6x to the 5th plus 18x to the 7th minus 30x is the same as 6x times the quantity of x to the 4th plus 3x to the 6th minus 5. These are the same things written in 2 different ways. It's going to come in handy later when we learn how to solve these types of equations. You might need to factor them first. But again, it doesn't have an equal to sign, so we still haven't found out what x is, what the solution is, because it's not an equation, it's an expression. Okay, that includes this review. We are going to have a couple more reviews. And then I will bring back these concepts as we use them. Don't forget to do your homework, and continue to practice and watch the video as necessary.